The eastern desert frontier was not a line on a map. It was a chain of work that ran between counted supplies in the Nile Valley and measured water on the desert track. It connected river depots to stone stations, and it connected those stations to Red Sea ports and quarry zones. A frontier in this setting means distance crossed in stages, with water planned and checked at each stop. It also means routine authority, because movement without water points turns into delay, and delay turns into wasted water and failed loads. In this episode, the Eastern Desert is treated as a frontier system. The focus stays on geography, forts, patrol routines, and daily work inside small posts. The desert forces practical choices because heat and dryness punish mistakes, and because dust wears straps, hinges, and leather. For that reason, the frontier becomes a repeatable sequence of actions. People measure water, seal containers, check loads, and record arrivals. They keep routes usable by keeping stations supplied, by keeping cistern mouths covered, and by keeping stage timing consistent. There is no dramatic storytelling here. The Eastern Desert is approached through structure. We will move slowly from the purpose of the corridor to the terrain that shapes it, to the posts and stations that hold it together. Then we will look at patrol patterns that are driven by stages and water discipline. We will end with daily life as routine maintenance in a hot and dusty environment. Calm comes from repetition that stays the same, because wells, cistern openings, and sealed jars force the same questions to be answered again and again. The Roman state could not rely on one large fort in this region. The distances between the Nile and the Red Sea corridor, and the gaps between Wadis and reliable water, demanded a series of smaller installations. A station could be a guarded cistern, a shelter with a small gate, or a minor fortlet that held tools and spare skins. A larger fort might sit where several tracks met, or where a pass narrowed movement across a rocky plateau. The logic is practical. The desert favors nodes and intervals, not continuous walls. A few Egypt-specific anchors will appear in a light way. The Nile Valley will serve as the counting world where grain and containers are issued by measure. Places like Koptos acted as transfer points where river transport became desert transport, and where loads were checked before the track began. Red Sea ports such as Berenike or Myos Hormos depended on these stage chains, because their water and food had to be counted and moved across dry ground. Quarry zones such as Mons Claudianus and Mons Porphyrites also depended on this corridor logic, because extraction and transport required water issued by measure at predictable stations. The approach remains impersonal and procedural. Each chapter returns to the same objects: water skins, amphorae, jar stoppers, seals, straps, station gates, and brief notes of arrival. In a desert frontier, these objects are not background detail. They are the system itself. Every paragraph stays tied to Eastern Desert work: water points, cistern covers, sealed jars, and stage timing, wadi routes, passes, and track markers, dust wear on straps and sandals, and repairs that keep a gate closing. The structure comes from repeating these constraints and repeating the same actions. We begin with where the corridor sits, and why a chain of water points could function as a frontier. Chapter 1 considers where the Eastern Desert frontier sits, and why it mattered to Roman Egypt. because location here is practical rather than symbolic. The region lies between the Nile Valley and the Red Sea, with routes running across dry ground through wadis and over rocky plateaus. In this environment, a frontier is not a continuous edge. It is a managed corridor made of stations, water points, and controlled turns on the track. Control attaches to wells and cistern mouths, because those points decide whether a travelers can continue to the next stage. The corridor mattered because the Nile Valley was both a productive base and an administrative base. Supplies could be counted and issued in river towns, then converted into sealed loads for desert transport. Once loads left the river, they entered heat, dust, and limited water. For that reason, the state needed predictability in movement. It achieved that by placing stations at intervals, by protecting wells and cisterns, and by treating travel as a sequence of stages rather than as one long push across dry ground. A frontier in this setting also meant surveillance shaped by necessity. Because travellers were forced toward the same water points, the state could concentrate watchers at those nodes. A small post at a cistern could observe who arrived, who departed, and whether containers appeared sealed or depleted. This kind of authority does not require constant conflict. It is routine processing at a gate near water. The desert assists the process because dryness reduces alternatives and makes the official route the sensible route. The Red Sea side of the corridor adds another reason for the system to exist. Ports depended on supplies that did not grow locally, and ships required steady provisioning. A corridor of stations allowed goods and people to reach places like Berenike or Myos Hormos without relying on chance wells. The frontier, therefore, is the protected route itself. It is the chain of controlled water points and guarded shelters that keeps a port a dependable node within a dry landscape. Quarry zones in the eastern desert show the same logic with a different destination. Extraction sites required labour, tools, and transport, and they required water for people and animals working under heat. A station chain made it possible to move heavy stone in scheduled convoys, because animals and handlers needed water issued by measure at predictable stops. Even when a quarry lay inland, the same corridor rules applied. Water points anchored the route, and the route anchored authority at station gates. A brief note from an ancient author follows. Strabo describes routes from the Nile toward the Red Sea and treats travel as dependent on wells and stopping places across the desert. His perspective is interval-based. It assumes that progress is measured from station to station, where water and rest can be obtained. That is the same structural idea as a frontier corridor, built on planned stops rather than on a single boundary. The Roman presence in the eastern desert is visible through evidence tied to movement. Trackways and road alignments connect one water point to another. Small forts and stations appear where the route can be controlled, often near a pass or a wadi junction that forces travellers into a narrow channel. Water infrastructure, especially cisterns and protected wells, appears as a repeated anchor. In a dry corridor, a small gate and a covered opening can be more effective than a large wall built far from water. The corridor also worked because it reduced choice in a controlled way. A traveller does not need to be chased if the only viable route is the one with stations. Because desert travel consumes water predictably, most movement remains close to the stage chain. That makes it possible to enforce routine rules. People are directed to the next stop. They are discouraged from lingering in shade. They are expected to keep containers sealed and straps sound. These are ordinary instructions, but in a dry environment, they create compliance without spectacle. This helps explain why the eastern desert frontier can feel quiet in its daily rhythm. The constraints do not change often. Water remains limited, distances remain fixed, and heat continues to wear materials. Therefore, the system repeats the same checks. How much water is sealed? How far the next station is? Which pass or wadi line is used? Whether the straps and jar stoppers will survive another stage in dust. The frontier becomes a schedule verified by objects, not a story driven by exceptional events. The term frontier can also be understood as the point where different transport worlds meet. At departure points such as plateaus, river movement becomes track movement. Loads that once sat in boats are now bound to pack frames with straps that must be retied under heat. Water that could be drawn from the river must now be carried and rationed in skins and jars. This conversion is why the first desert stages are controlled. If sealing and loading are done poorly at the start, the losses appear later at the next water point, when a station finds broken stoppers or loosened straps. Administrative logic sits close to these physical facts. A corridor needs a definition of who can draw water, when, and how much, because measured issue preserves the cistern for the next stage. A station also needs to know which groups are expected, because an unexpected convoy changes jar counts and shade capacity. For that reason, even a small post treats time and water as items that can be supervised. The supervision is quiet. It is a guard at a gate, a measure at a cistern, and an instruction that ties departure time to the next station. By the end of this chapter, the definition can remain simple and concrete. The eastern desert frontier is a chain of controlled points that keeps movement possible across a dry gap. Because the gap is dry, the control is not abstract. It sits on wells, cistern mouths, sealed containers, and the rules of stage travel that direct people from one station gate to the next. A corridor frontier also depends on simple verification. A post can compare a group's stated route to the known stage chain, because the next water point is fixed and the wadi line is known. It can count jars, check stoppers, and look for broken seals before issuing water, because broken seals invite dust and evaporation. These checks are quiet, but they make the desert route legible to the administration, because they turn movement into counted departures and counted arrivals. Chapter 2: Geography and Movement. The eastern desert is built from rocky plateaus, ridges, and long wadi systems that guide travel into channels. A wadi can provide a gentler gradient and a clearer path, but it also concentrates movement and limits sideways options. That concentration is useful for control, because a watchpost can face a wadi line and observe dust trails on the track, and because a station can predict where travellers must pass. The terrain also shapes where stations can sit, because stations require some relationship to water. In many stretches, reliable water is rare, so a well, a spring, or a cistern fed by runoff becomes a node. Where no water exists, a shelter may still appear, but it cannot function as a full stage stop. Therefore, stage lengths are not chosen only by distance. They are chosen by container capacity and by the location of water points that can be protected behind a small gate and a covered opening. Heat and dryness change the cost of time, so movement becomes a balance between speed and consumption. A faster pace can reduce exposure and shorten time between water points, but it can also increase sweating, increase animal strain, and lead to faster water use. A slower pace reduces strain, but it increases the hours spent in the open, and it increases the chance that a stage ends late. For that reason, travel in this corridor tends to follow planned departures and planned arrivals. Timekeeping becomes a practical tool. It links the last water issue to the next station, and it allows a post to judge whether a party is on schedule or consuming more water than planned. Water discipline has a physical form because water is carried in skins, jars, and amphorae that can fail. Seams dry and split. Stoppers shrink and loosen. Straps rub through in grit. Therefore, movement includes repeated inspection. Containers are covered to reduce dust entry. Openings are sealed and checked by touch. Loads are balanced so jars do not grind against each other. The desert turns these small actions into the difference between reaching the next cistern and arriving short of water. Animals and handlers are part of the constraint. Pack animals need water, and their condition affects the stage. If an animal slows, the party spends more time in heat and uses more water. Therefore, loads are adjusted and redistributed in response to desert wear. A station keeps spare straps and simple tools for this reason, because a broken strap at the start of a stage is easier to fix than a spilled jar on the track. This is a calm chain. Condition affects pace. Pace affects water. And water affects the ability to reach the next stop. Visibility and navigation become routine constraints rather than exploration. Open plateaus can provide long sight lines, but haze and dust can flatten the landscape and make landmarks hard to judge. Wadi bends and passes break visibility and create places where a party can drift off the main track. That is why markers matter. Cairns, stone lines, and known waypoints reduce wrong turns that waste water. A wrong turn is not only a geographic error, it is a consumption error because it converts planned water into unplanned distance. Rest intervals during a stage are shaped by container care rather than comfort. A halt is a moment to check for leaks, retie knots, and adjust straps that have shifted under heat. It is also a moment to check whether a party can still reach the next station within the planned hours, because delay changes water use and changes what the next station must issue. For that reason, rest has a controlled character. It stays short, it happens in shade when available, and it includes practical checks on skins and stoppers so that the stage plan remains realistic. Here is one micro-procedure, described as a repeatable water issue cycle. The guard checks the cistern opening and clears grit from the rim, because dust can fall into the water during handling. A responsible person inspects jars and skins and sets aside any with cracked stoppers or torn seams, because failure on the track creates loss for the whole stage. Water is measured with a fixed vessel, and the measure stays consistent because equal issue prevents waste and argument. The filled containers are sealed at once, and the stopper is pressed and checked because an unsealed opening invites dust and evaporation. The guard records the number of filled containers and the names or group because the station must track what leaves. The cistern opening is covered again because every open minute adds grit. The party departs with a defined allowance because a defined allowance creates a defined stage. Stage planning follows directly from this cycle because issue by measure defines how far a party can go. If the next station is farther, more containers must be carried, which increases strap strain and increases inspection needs. If the next station is closer, fewer containers may be needed, which reduces load weight but still requires sealed openings against dust. Therefore, geography and logistics merge into one rule. The route is the place where container capacity matches station spacing, and where stations exist because water can be held and protected. The desert also shapes what happens when something changes on the route, and the response is usually procedural. If a station receives runoff and its cistern level rises, it still clears silt from the mouth and protects the opening from dust because storage is only useful when water stays clean. If a wadi segment becomes rough after stone movement, a patrol adjusts timing and uses a safer pass line because timing determines how much water a party needs to draw. If a party arrives late, the station measures again and decides whether to issue a supplement because the next stage still has fixed distance and fixed water points. By the end of this chapter, movement can be described as a discipline shaped by objects. Wadis guide travel, plateaus offer sight lines, passes focus control, and water points fix stage length. Each constraint produces a routine action: measure, seal, cover, retie, and keep departure aligned with the next station. In the Eastern Desert, calm emerges from doing these actions the same way because the landscape rewards repeatable procedure. Different container types shape different routines. A skin can be light, but seams suffer under heat and must be checked for drying and cracking. A jar or amphora can be more stable, but stoppers loosen, and the rim collects grit when it is opened. For that reason, a station keeps cloth covers, spare stoppers, and simple seal material, because dust and evaporation are everyday losses. The routine is to prevent loss before departure, rather than to explain it after arrival. In practice, a stage in the Eastern Desert is planned by comparing distance to carried water, and then adjusting pace to protect that allowance. A rocky plateau may look open, but it forces a steady step because ankles and hooves are punished by loose stone and sharp edges. For that reason, time is treated as a measurable input. If a wadi segment slows the column, the delay is not only fatigue. It is extra mouthfuls from a skin and extra sips taken before the next cistern can be reached. Stations therefore think in intervals. They estimate the hours to the next water point, and they relate that estimate to the number of sealed containers leaving the gate. If a party wants to depart with fewer jars, the station does not argue in general terms. It points to the next stage length and to the heat on the track, and it requires a correction. The correction stays concrete. Add one skin, shift one jar to a stronger strap, and press the stopper until it seats cleanly. In a dry corridor, these small adjustments decide whether the party reaches the next station without demanding an emergency supplement. Even short halts on the track are planned around container survival. A stop is a moment to feel a seam, retie a knot, and confirm that a stopper has not lifted as a jar knocked against a pack frame. It is also a moment to compare progress to the planned arrival hour, because a late arrival increases pressure on the next station's measured issue and its shade capacity. For that reason, halts stay brief and functional. They are maintenance pauses that reduce loss of water to leakage and reduce wear to straps that grind through under dust. Navigation has the same practical character. Cairns and stone lines are not decoration. They prevent wrong turns that convert planned water into wasted distance. In broad wadis, many side channels look similar, and a small drift can hide the track behind low ridges and dry gravel bars. When that happens, the party spends minutes searching, and those minutes become water consumed. Therefore, the route is kept legible on purpose. Markers are rebuilt when they collapse, and turns are clarified where a wadi forks, because clarity preserves the stage plan. The desert also enforces discipline about shade and exposure. If the group extends rest too long, containers warm, seams dry, and straps loosen. That increases risk on the next hours of walking, because failure happens when heat and friction combine. So stage planners prefer a steady rhythm. Depart on time, keep the load balanced, and reach the next station before improvisation begins. This is why movement in the corridor looks repetitive. The same stage lengths, the same wadi turns, and the same checks on stoppers and straps keep the track usable from one day to the next. Chapter 3: Forts, Posts, and the Roman Footprint. Chapter 3 describes forts, posts, and the Roman footprint, because the corridor is held together by installations designed for water and staged movement. In the eastern desert, a post is often small, but it is organized around controlled access to storage and to a water point. A station may combine a cistern, a storeroom for jars and skins, and a simple gate that limits entry. Wall height matters less than the ability to lock the water store, cover the cistern mouth, and assign a guard to the opening through the day. Along major routes from the Nile toward the Red Sea, the Roman presence is best understood as a chain. Koptos is a useful anchor as a transfer point because it sits in the Nile world of counting and writing, and it connects to tracks where loads are checked before the first dry stage. After that conversion from river to track, stations take over. Each station provides a predictable interval, and it provides shelter where containers can be shaded, sealed, and inspected. The chain logic also allows the state to concentrate effort. It repairs and guards specific nodes, rather than trying to occupy the whole rocky plateau. Installations vary in scale, but their roles remain clear. A larger fort can hold a small garrison, store tools, and keep spare straps, nails, and hinges that suffer under heat and grit. A minor fortlet or watch post can do less, but it can watch a pass and face a track segment where travellers must appear. Way stations can be simpler, with a courtyard, a store, and a protected water feature, but they still support stage travel by offering a gate and a routine checkpoint. What matters is definition of function. Guard water, protect storage, control passage, support repairs, keep the next stage possible. Inside a small fort, the layout supports routine work tied to desert degradation. Storage spaces are set aside for water jars, for grain in sacks, and for oil containers that must be kept closed against dust. Working areas exist for repairs because leather, wood, and rope dry out and crack. A sentry point faces the track because seeing a dust plume early gives time to prepare the gate and the water issue. A small command space supports rosters because patrol timing depends on who is assigned to which stage and who remains on water duty. The water feature inside or near a station is treated as an engineered object. A cistern needs lining and maintenance so stored water does not seep away. Its mouth needs a cover that fits, and that cover needs a latch or seal to prevent dust and casual access. Gutters or channels that guide rare runoff towards storage need clearing because silt reduces capacity and blocks flow. This kind of work is quiet but constant. It is also one reason why posts need tools and spare fittings, because the desert does not preserve structures without effort. Quarry zones such as Mons Claudianus or Mons Porphyrites show the same corridor logic with a different cargo. The work is extraction rather than port supply, but it still depends on water and scheduled transport. Stone is heavy, so loads strain animals and straps, and that increases the need for repairs at stations. Water is needed for workers and animals, and it must be issued by measure to prevent waste in heat. For that reason, quarry-related installations often include strong storage and control features, because losing water means losing labour time and losing transport capacity. A brief note from an ancient author follows. Pliny the Elder discusses valuable stones and the labour required to obtain them, and his perspective assumes organised work in difficult environments. He does not treat extraction as casual. He treats it as planned effort, because distance and transport make planning unavoidable. That assumption fits the station chain idea, where water points, storerooms, and controlled departures make heavy movement possible across dry ground. Roads and trackways in the eastern desert can be subtle on the surface, but their structure is consistent. They connect one water point to the next, and they often follow wadi lines or pass routes where travel is physically feasible. Stations sometimes sit where runoff can be captured into cisterns, because even rare water can be stored if the opening is protected and the walls are maintained. Over time, the station chain becomes a map of constraints. It marks where water can be held, where gates can be placed, and where a patrol can time its stage reliably. Watchposts take advantage of the plateau in a specific way. On higher ground, a small post can observe movement along a track because dust trails show from a distance. This does not create drama. It creates preparation. If a caravan approaches, the station can ready its gate check and set water containers into shade. If no caravan appears by the expected stage time, the post can note a delay and plan a messenger. In a desert corridor, observation is tied to timing, and timing is tied to water. Buildings in this region reflect practical priorities. Stone walls provide durability against wind and grit, but they still need maintenance at doors, hinges, and roof coverings. Openings are kept narrow to reduce dust entry into stores. Thresholds are swept, not for comfort, but because grit damages jar bases and makes seals less reliable when stoppers are set on dirty rims. Even the placement of a storeroom matters, because a cooler interior helps preserve water and food in sealed containers that would otherwise degrade in heat. The footprint can be summarized as a network of nodes designed around desert facts: limited water, abrasive dust, and fixed stage distances. Forts, fortlets, watchposts, and way stations keep the corridor stable by guarding water points, maintaining track access, and providing places where loads can be checked and protected before the next dry interval. A garrison's internal organization is shaped by water and stages. Duty is divided in a way that matches the corridor. Someone is responsible for the water store and the cistern cover. Someone is responsible for the gate and for checking seals and straps as loads enter. Someone is responsible for repairs because leather and rope fail under desert heat. These roles can rotate, but the tasks remain the same. The post stays functional when each task has a name attached to it, because responsibility keeps the cistern covered and keeps the next stage realistic. A station also keeps its water infrastructure usable by small inspections. Plaster linings are checked for cracks because seepage wastes stored runoff. The cistern cover is tested for fit because wind-driven grit will enter any gap. The same tools used for hinges and straps can also clear sediment because sediment reduces capacity and affects the next stage issue. Chapter 4: Patrols, Watching, and Routine Security. Chapter 4 focuses on patrols, watching, and routine security, and here the desert forces a specific logic. Patrols are planned as stage movements between stations because water consumption makes timing strict. If a patrol leaves late, it risks arriving after the planned water issue window at the next cistern. If it arrives too early, it can disrupt the station's measured allocation and shade storage for jars. Therefore, patrol schedules are not only about observation. They are about aligning departures, arrivals, and measured water handling along the corridor. A patrol in this corridor does not wander widely, because wandering consumes water without improving control. It follows known track segments between controlled points, because the purpose is to confirm that the route remains usable and supervised. In practice, the patrol checks cairn markers, verifies that the Wadi line is passable, and looks for signs of drift off the track that could cause a party to miss the next station. It also checks the condition of straps and skins on its own load, because a leaking skin turns a planned stage into an unplanned shortage. Because delay consumes water, handovers become a core security tool. A station needs to know whether a patrol is on time and whether it carries enough sealed water to reach the next stop. If that information is unclear, the station must either issue extra water, risking shortage, or refuse issue, risking failure of the patrol stage. For that reason, routine communication is kept short and concrete. It focuses on departure time, container condition, and the next intended station, because these three facts control water consumption and stage feasibility. Here is one micro-procedure described as a repeatable patrol handover cycle. The relief time is fixed because the stage plan depends on predictable departures. The outgoing patrol presents its equipment, and straps and sandals are checked because desert wear can cause sudden failure between stations. Water skins and jars are inspected at the stoppers, and seals are confirmed because a broken seal suggests loss or contamination. A brief written note is made with names, the time, and the next station, because the next post must prepare its measured issue. The note is kept short because the content must travel easily. The incoming patrol takes the same water allowance and confirms its route, because uncertainty en route becomes wasted water. The station gate closes behind them, because control of the water store matters as much as the patrol itself. Signals and visibility are tied to stages and water rather than excitement. On open plateaus, a post can watch for dust plumes along the track, and a delayed plume becomes a practical concern. The station prepares shade space for arriving jars, and it considers whether a measured supplement may be needed for animals. In narrow passes and wadi bends, visibility fails, so time becomes the signal. If the expected arrival time passes, the station decides whether to send a messenger to the next point, because the stage chain is a series of fixed distances tied to fixed water points. Controlled movement is enforced through routine checks at gates and water points. A traveller who arrives at a station is asked where they came from and where they will go next, because the answer must fit the stage chain. They are asked about water carried, because an undersupplied party creates pressure on the station's cistern and its measured issue. They are directed to depart within a timetable, because lingering consumes shade and increases water draw. None of this requires drama. It is a plain control of stage traffic, using questions that relate to the next water point and to the next wadi segment. Security also applies to convoys and escorts in a dry corridor. A stone convoy from a quarry or a supply convoy toward a Red Sea port cannot pause indefinitely, because animals and handlers consume water each hour. Therefore, an escort's job is partly to keep the stage plan intact. It keeps the group on the marked track, prevents dispersal toward uncertain wadis, and confirms that water containers remain sealed. The goal is to keep the convoy within the interval the next station expects, so measured issue can remain measured and the cistern cover can be closed again. Information moves in small documents rather than in grand reports, and this is where the system becomes visible without academic framing. A potsherd note can list names, a container count, and an arrival time at a station gate. Another note can record that a wadi segment required slower pace, because that detail affects stage timing and therefore water issue. These notes are brief because the purpose is brief. Keep the next station informed so it can measure water, arrange shade, and plan the next departure without guessing. When a party becomes overdue, the response is still stage-driven. The station compares the expected arrival time to the water carried out on the last issue, because water capacity defines how long a delay can be tolerated. If the tolerance is passed, a messenger can be sent to the previous station, not to search the open desert, but to confirm whether departure was recorded and whether the party took the correct track. If necessary, a patrol is sent along the marked segment to the next water point, because the next water point is the only place a delayed party is likely to aim for. Security in the desert also includes prevention of contamination and theft, because water is valuable and fragile. Cistern openings are covered and secured, and the cover is checked at each shift, because dust and tampering both threaten storage. Jars are stored in shade and counted, because heat increases loss, and because missing containers mean missing water capacity. The gate is controlled, because uncontrolled access to water undermines the stage plan. Therefore, much of security is infrastructure protection, and the infrastructure is often nothing more than a cover, a latch, a storeroom, and a roster of who holds the key. By the end of this chapter, patrols appear as boring reliability. They keep the corridor predictable by keeping stages aligned. They watch tracks, they check markers, they confirm seals, and they carry short notes between stations. Because the desert punishes delay with water loss, the frontier becomes a strict schedule. That schedule is security in practical form, built from water, time, and controlled station gates. Routine security is often indistinguishable from routine scheduling. A station that expects a convoy toward a Red Sea port prepares shade space for jars and checks its own jar count before arrival, because it will need to issue water quickly and close the cistern cover again. A station that expects a quarry convoy checks strap material and pack frames, because heavier loads increase wear and increase the risk of delays that consume water. The security outcome is produced by preparation, because preparation prevents water-driven improvisation at the gate. Because the corridor is built from stages, a patrol's main output is accurate timing. The patrol confirms that the interval to the next station still matches the water allowance carried out of the last gate. If a wadi bend has become slower, or if loose gravel on a pass forces a careful pace, the patrol does not describe it as a vague difficulty. It notes the minutes added, because minutes become sips, and sips become a change in measured issue at the next cistern mouth. For that reason, routine security often looks like schedule protection. Stations reduce risk by keeping departures aligned with the next water point, and by preventing unscheduled lingering that consumes water without moving the stage forward. When a group arrives, the post checks whether jars and skins remain sealed, because broken stoppers invite dust and show uncontrolled use. It then ties the group to a clear departure hour, because a defined hour preserves the chain of stations and prevents a delay from spreading along the track. Small documentation supports this rhythm without ceremony. A brief note can list the group, a container count, an arrival hour, and the named next station. Another note can record that a patrol found a cairn disturbed at a fork in the Wadi line, because a missing marker leads to wrong turns and overdue arrivals. These notes are practical. They allow the next station to prepare shade space, set its measuring vessel ready, and decide whether a messenger should be sent if the expected dust plume does not appear on time. Gate control becomes a water protection task. The post restricts access to the cistern cover and the jar store, because a station can only issue what it can keep clean and accounted for. The guard checks straps and knots before allowing a party to move on, because failure on the track forces stops that consume water and break the expected timetable. Even questions at the gate are stage questions. Where did you last draw water? Which pass or wadi line will you follow? How many sealed containers remain? The answers are checked against the route's fixed intervals, because fixed intervals are the basis of measured issue. When delays occur, the response stays interval-based. The station compares the recorded departure hour with the expected travel time, because that comparison estimates whether the party still has sealed water. If the party is overdue beyond what its allowance could support, the post does not scatter men across the plateau at random. It sends a messenger along the marked segment toward the next station, because the next station is where an overdue party will aim if it can still move. If the next station reports no arrival, the record becomes clearer, and the next patrol can be directed to the correct Wadi line rather than wasting water on broad searching. In this way, enforcement remains calm because it is tied to scarcity. A station may refuse extra water to travellers who cannot give a consistent stage plan, because extra issue risks the next patrol and the next convoy. It may require the group to wait until a scheduled allotment can be measured, because unmeasured issue encourages waste. It may direct movement away from side tracks that lack reliable water points, because such detours turn into rescue demands. The security result is produced by keeping water, time, and route clarity aligned. Chapter 5: Daily Life in an Eastern Desert Garrison. Chapter 5 turns to daily life in an Eastern Desert Garrison, where routine is shaped by water handling and by heat damage to materials. The day begins with checks because the desert does not pause. Cistern covers are inspected for gaps where dust can enter, and jar stoppers are checked for dryness and cracks. Shade structures are examined because direct sun warms water and spoils food stored in closed containers. These actions are baseline tasks that keep the station chain functional, because a failure at a cistern mouth affects the next stage and the next patrol departure. Water storage sits at the center of interior routine. Jars and skins are arranged so that air can circulate and so that older containers can be used first. Sediment is monitored because desert grit finds its way into openings despite care, especially when the cistern mouth is opened repeatedly for issue. A small amount of scraping at the rim becomes a repeated task because contamination spreads quickly when water is scarce. Therefore, cleaning is planned, and it is tied to the roster, because responsibility keeps water safer than improvisation. Food preparation is simple and constrained by supply and storage. Much of the grain supply is issued and counted in the Nile Valley, then moved across the track in sacks and sealed jars. Inside the post, bread production depends on fuel and on the ability to keep flour away from dust. Oil, wine, and salt appear as routine items because they store well in closed containers and can be issued by measure. Local purchase or exchange may supplement at times, but the station still treats food as scheduled issue because the corridor depends on predictable consumption between water points. Water use affects more than drinking. Washing is limited because water is carried and measured, so cleaning becomes targeted and procedural. Containers are rinsed only when necessary, and the rinse water is controlled so it does not contaminate the storage area with wet grit. Cloth is shaken and brushed rather than soaked, because soaking requires extra water and creates mud that attracts dust. Latrine areas are managed to protect water from contamination, because a small station cannot afford sickness that reduces the labour available for patrol stages and gate checks. Maintenance work fills the day because the environment is abrasive. Sandals wear quickly on rocky ground and in wadi gravel. Straps cut into fibre under heat, and knots loosen when rope dries. Leather must be oiled and patched, because dryness stiffens it and makes seams fail. Hinges and latches collect grit, so they are cleaned and reseated, because a gate that does not close risks the water store and the jar count. Even pottery demands attention, because a cracked jar leaks slowly and can ruin a stage plan by reducing carried water. The station also has a rhythm of inspection linked to arrivals, because each arrival is also a departure in preparation. Loads come in from one stage and must be made ready for the next. Containers are set down in shade, and straps are loosened to reduce friction damage. The post checks whether a jar stopper is seated, because a loose stopper means evaporation and dust entry. The post checks whether the party's planned departure time remains possible, because delay changes water use and changes what the next station must issue. The desert ties arrival, storage, and departure into one continuous chain. Here is one micro-procedure described as a repeatable gate and load inspection cycle. At the gate, the guard looks first at seals and stoppers, because sealed containers protect water and oil from dust. Straps and knots are examined and retied where needed, because a failed strap between stations wastes water and time. The traveller is asked simple questions about last station and next station, because the answer must match the stage chain. Containers are counted and compared to an expected load, because count reveals loss and reveals whether a party can reach the next water point. The guard points out the next route segment and the next Wadi line, because clarity prevents wrong turns. If needed, the post routes the party to rest briefly in shade, because a short controlled pause is better than an uncontrolled delay on the track. A note is made for the station record, because a record supports measured issue and supports planning for the next arrival. Sleeping arrangements are functional and shaped by heat management and controlled storage. People rest where shade and airflow exist, and where stored water remains protected behind a gate. Bedding is simple, and the emphasis is on keeping dust out of containers rather than comfort. The roster assigns night and day duties, because cistern covers and gates need checks at fixed intervals, and because patrol departures depend on the stage plan. Therefore, sleep exists inside the system. It is part of the schedule that keeps the corridor stable. Small tasks repeat because the station must remain usable under continuous dust. Jars are moved to reduce heat exposure, and skins are hung so seams dry evenly without cracking. Tools are stored to avoid grit in joints, and spare parts are kept in wrapped bundles so hinges and nails do not scatter. Fuel is conserved because transport from the Nile costs effort, and because port and quarry needs compete for the same stage capacity. These constraints keep daily life plain. Store, protect, repair, and preserve the ability to issue water again. Documentation appears quietly in the daily rhythm, and this is the second brief moment that shows what routine recording looks like. A short roster note can list the names assigned to water duty and gate duty. Another line can note the number of jars issued and the hour a party departed toward the next station. The writing is not formal literature. It is a way to connect measured water to responsibility in a corridor where a cistern opening and a container count are the main facts that matter. Ration enforcement works best when it is mechanical. A fixed measure reduces argument, seals reduce tampering. A counted store reduces quiet loss. Because each station depends on the next, a garrison learns to treat small deviations as practical risks. It corrects them by checking stoppers, counting jars, and matching departures to the stage plan. By the end of this chapter, calm comes from maintenance and measurable routine. It comes from patching leather, scraping grit, retightening straps, and keeping the cistern mouth covered. It comes from cooking with counted supplies and storing jars in shade. It also comes from short records that keep the stage chain coherent. In the Eastern Desert, daily life is the work that allows the next departure to happen on time. Fuel and cooking are also controlled because fuel must be carried across the track. Fires are kept small, and ash is cleared so it does not mix with dust that can settle into food containers. When bread or porridge is prepared, water is measured, because every extra ladle reduces what remains for drinking on the next patrol stage. The desert makes the kitchen part of water accounting, not a separate world. Chapter 6: Return to Quiet Function. Chapter 6 returns to quiet function because the frontier continues as a loop of objects and actions. The Eastern Desert Corridor stays stable when each station performs the same set of checks with the same materials. Cistern openings are inspected and covered. Jar stoppers are tested and reseated. Seals are confirmed. Straps are retied. Sandals are patched. Hinges are cleared of grit so a gate can close. These small acts decide whether the next stage remains possible across dry ground. The loop can be described in concrete terms because the desert forces concreteness. A roster assigns a guard to the gate and another to the water store. A fixed measure is used to issue water into skins and jars, and the containers are sealed and covered. A short note records a name, a time, and a container count. A patrol departs along a wadi track, checks cairn markers at turns, and arrives at the next station within the planned interval. That station repeats the same checks because the same heat and the same dust produce the same failures if they are not prevented. Authority in this setting remains practical and local. A gate is closed to protect the cistern and to control access to stored jars. Travellers are questioned briefly because an incorrect destination wastes water and creates pressure on the next station's issue. Loads are placed into shade because heat increases loss from skins and jars and increases spoilage risk for food containers. A strap that looks worn is replaced before departure because failure on the track forces an unscheduled stop that consumes water and disrupts the stage chain. The corridor stays quiet because it does not depend on constant improvisation. When a strap fails, it is replaced from a store. When a jar leaks, it is set aside and the count is adjusted before the next issue. When a wadi segment becomes difficult, a patrol note changes the stage timing and warns the next station to prepare its measured water differently. Each adjustment is small because the system is built to absorb small failures through repair and record. The desert keeps the feedback loop short. A mistake becomes visible quickly at the next cistern mouth when water is measured and jars are counted. The stage chain connects different destinations without changing its inner logic. A supply movement toward a Red Sea port follows the same pattern. Containers are sealed at the start, checked at the gate, carried to the next water point, and recorded on arrival. A quarry convoy follows the same pattern, even though it carries heavier loads. The straps must be stronger, the pace may be slower, and the water requirement may be higher. but the station chain remains the same. It provides a gate, a store, a measured issue, and a record that links one stage to the next. The Nile Valley remains the background base because it is where much of the counting happens. Grain and oil are issued there, then turned into sealed loads at departure points such as plateaus, and then passed along stations toward Red Sea nodes like Berenike. Each movement across the desert is a conversion of supply into water-supported transport. For that reason, the frontier is not distant from administration. It is the place where administration meets heat, dust, and limited wells, and where success is measured in intact seals and on-time arrivals at stations. Over weeks and months, the same objects keep returning. A jar stopper must be replaced when it dries and shrinks. A seal must be checked because dust hides small breaks. A cistern mouth must be scraped and covered because sand falls every day. A roster must be read because duty rotates and because fatigue affects careful measuring. A track marker must be restored when stones shift. These are small jobs, but they are stable jobs. They are repeated because the desert repeats its pressures and because a corridor only functions when routine stays continuous. A desert frontier also settles into predictable handoffs between stations. One post does not need to know the whole landscape. It needs to know the next interval. It needs to know how much water was issued, how many jars were sealed, and what time the last party departed. Therefore, closure in this episode is also local. It returns to the next station gate, the next cistern cover, and the next departure hour. The system continues because each node repeats its duties, and because each node relies on the next node to do the same. The closure is a restatement of routine with objects, not a slogan. Cover the cistern mouth, check the seal on a jar stopper, retie a strap that is frayed from grit, read the roster for water duty, record an arrival time on a shard, set containers into shade, confirm the next departure hour and the next station name, send a messenger with a brief count, depart toward the next water point along the marked track. These actions are repetitive because the constraints are repetitive, and because stations survive by keeping water measurable and movement staged. The eastern desert frontier, seen this way, is calm because it is stable work. It is built from stations, intervals, and careful handling of water and containers. It is maintained by inspection, by short records, and by patrols that keep stage timing aligned. In the end, the system continues because the desert does not change its demands. The same cisterns, the same jars, the same seals, and the same departure times keep the corridor functioning from one day to the next. The system continues because it builds short feedback into the stage chain. If a station records that a party arrived with broken seals, the next station tightens its gate check, because broken seals usually mean loss of water or dust contamination. If a patrol reports that a cairn marker has shifted, a small repair is scheduled, because a wrong turn wastes water and creates overdue arrivals. If a jar count declines, the post adjusts how many containers it can issue, because issue depends on physical storage and not on wish. A final concrete loop can hold the episode together. A guard touches the cistern cover and confirms it is seated. A measure is filled and emptied into a skin, and the stopper is pressed in place. A seal is checked on a jar, and a strap is tightened on a pack frame. A roster line assigns the next watch at the station gate. A short note marks the hour a party departed toward the next water point. Then the post waits for the next dust plume on the track, and the next scheduled handover begins. Even when the corridor serves different tasks, the closing pattern does not change. A port supply chain, a quarry convoy, and a routine patrol all meet at the same station gate and the same cistern mouth. Each one requires sealed containers, intact straps, and a recorded time of departure. That is why the system can continue without constant innovation. It repeats because the desert repeats the same demands. The corridor continues because each station treats water and time as items that can be handled and verified. At the start of a shift, the guard checks the cistern cover, confirms the latch, and wipes grit from the rim before opening it. He checks the measuring vessel and the jar count in the storeroom, because issue depends on what is physically present and what can be sealed. If the count is low, the station reduces what it will allocate, because over-issue today becomes shortage for later patrols and later convoys. The same logic applies to straps and closures, because Eastern Desert wear creates small failures that spread into schedule problems. A frayed strap is replaced before departure, not after a spill. A jar stopper is pressed and tested, because a loose seal invites dust and slow loss under heat. Hinges and bolts at the gate are cleaned, because grit keeps a door from closing, and an open door threatens the water store. These repairs are daily work that keeps a station able to close, lock, and protect its containers. Across the day, arrivals are processed in a consistent order, because order reduces wasted minutes at the gate and prevents unplanned water demand. Loads are set into shade, and seals are checked before any new water is issued, because the post must know what the party already carries into the next interval. Questions remain stage-based. The last station name, the next station name, and the intended wadi line or pass. The answers are compared to the known interval, because intervals define how much water can be allowed without harming the cistern reserve. Routine writing supports this sequence without ceremony. A short note can list names, an arrival hour, and a count of skins and jars that remain sealed. Another line can record a departure hour toward the next station, because the next gate prepares its measure and its shade space from that time. The writing is small, but it keeps the corridor legible. It ties a jar count to responsibility, and it ties a departure hour to expectation, which matters when heat and dust make guessing expensive on a dry track. This chain links the Nile Valley to the desert without changing the basic actions. Grain and oil begin as counted items near the river, and places such as Coptos convert them into packloads with straps, seals, and short written lines that travel with the convoy. Once the load is on the track, the Eastern Desert forces the same checks at every node. Jars are counted, stoppers are inspected, knots are retied, and the hour is recorded. When movement is bound for a Red Sea port such as Berenike, the destination changes, but the stage logic does not change, because the next water point still decides the next safe interval. Even landscape cues are treated as maintenance objects. Cairn markers at a fork are rebuilt when stones shift, because a wrong turn consumes water and produces an overdue arrival at the next gate. Track edges are cleared where drifting sand hides the line, because confusion on the route becomes delay, and delay becomes extra consumption from skins. A patrol note about a damaged marker stays short, but it is specific. It states the Wadi turn, the minutes added, and the next expected arrival window, so the next station can adjust its roster and its measuring schedule. So the closing loop stays concrete. The roster assigns water duty and gate duty. The cistern cover is opened, water is issued with the fixed measure, and the opening is covered again. Jars are counted, stoppers are seated, seals are checked, and straps are tightened. A departure hour is written down, and the party is routed to the next stage along the marked Wadi line. The station returns to its storeroom, its gate hinge, and its container count. Then the next arrival is processed in the same order, because the desert repeats the same constraints and rewards, the same careful actions.